Hello and welcome to a webinar hosted by World Pipelines with Tracerco. And thank you to everyone who is joining us. Welcome to you all. Today's session is Discovery, Enhancing Pipeline Integrity and Flow Assurance through Non-Intrusive Inspection over Strakes and Wax Detection. Joining me on screen is Jim Bramlett, Upstream Commercial Manager for the Americas at Tracerco. And Jim is going to showcase how Discovery enhances pipeline performance and integrity through advanced flow assurance monitoring and high-resolution, non-intrusive inspection capabilities. Soon you'll hear Jim's presentation, and then we'll follow this up with a Q&A session where he will happily answer your questions. If you'd like to submit a question at any point during the presentation or during the Q&A, here is how you do it. If you are joining us via a mobile or cell phone, you can access the question box by tapping the Q&A icon at the bottom of your screen. If instead you're on a desktop or a laptop, you can click the Q&A icon on the top right of your screen and then just click Ask a Question. Everyone who registered to attend today will receive a recording of the full presentation by email after we have finished. So you will be able to recap and watch again. So no need to take notes. You can just give your attention to Jim. All right, I'm going to hand over to you now, Jim, and I'll be back for the Q&A.
Great. I appreciate that, Elizabeth, and thanks to World Pipeline for inviting us to do this. But more importantly, thanks for everybody who's online. We know that your time is extremely valuable, and we appreciate you chiming in to let us show you a couple of case studies on some new applications or some new nuances to our technology that we've come up with, and we'll go through that. So a little bit about today's presentation. I'll do a quick intro, kind of who Tracerco is, a brief introduction of Discovery in case there's people online that are not familiar with the technology. And then we'll do our case study where we have done over-strake inspections, so no need to remove the strakes. We'll jump into some flow assurance, a couple of case studies with two different applications or two different nuances to our technology that we can use for wax detection, which is extremely difficult to do. And then we'll do a conclusion and then a quick Q&A. So be happy to answer your questions. So with that, kind of who is Tracerco? So Tracerco as a whole has been around for over 70 years now, started in the downstream world, kind of moved to the upstream world about 30-ish years ago. And within that, we specialize in difficult to measure applications, right? So very nuanced, and it's nuclear based for the most part. Even though when I say nuclear based, everybody worries about high radiation, so to speak. We use very, very small nucleonic sources. So if you can think of typical pipe X-ray, it uses Curie strength radiation. The bulk of our applications are in the millicurie strength radiation range, so extremely small amounts of radiation. Specific to our subsea technologies, we center around pig tracking, FMI, grout monitoring, buoyancy tank, Explorer for flow assurance for long lines. But today we're going to focus on our CT technology, which is specific to pipeline integrity as well as flow assurance, and it kind of does that all in the same. So again, today we're going to focus on our Discovery technology. So what is Discovery? Discovery technology is just like you would think. It's a CT technology. It's just exactly like you would think in the medical world, with a couple of differences, right? One is we don't use X-ray. X-ray, you would have to generate massive amounts of X-ray to try to penetrate the steel, the water, the very dense materials that we're trying to go through. Pipe and pipe, pipe and pipe and pipe. You know, very, very complex situations. Excuse me. So in other words, we switch from from X-ray to gamma ray, where we get a lot more punch power with a much smaller source. And obviously we're up to 10,000 feet subsea. We've actively been to 9950 feet below sea level. So very harsh environments versus sitting in a nice controlled air conditioned room in a medical facility, right? So unique challenge. The technology itself is kind of a clamshell, right? So it's fully integrated with the ROV. Although the ROV does not control our technology, we see clamp open. The ROV will fly in. We will be able to close around the pipe. And once we're on the pipe itself, we have full control to walk whatever distance we want to walk. So we're not bound by a range. We can do anywhere from single scans on flow assurance to, feet to multiple meters, all within 1 and 100% coverage. That technology, or our technology, is umbilical through the ROV. So again, once the ROV can deliver us to the pipe itself, the ROV can let go and hover. We are umbilical so that we can get our comms, electric, and hydraulic functions. And we get near real-time transition topside. So we get this data topside. We are looking at it, reviewing it, measuring it before we move to the next location. So that real-time data acquisition and understanding is quite important. And then the technology we talked about, it's flow assurance and asset integrity, right? That's a huge value add to the technology. So it doesn't matter whether we're out on an integrity as the primary focus. The client wants an integrity scan. We're also providing a health check on each of those spots that we scan to say, hey, here's what it looks like also internal to your pipe. Do you have any buildup? Do you not have any buildup? Are you in good shape? Is there something you need to be aware about? Can you start a remediation campaign early and knock something out before it becomes an issue? Vice versa. If the primary focus of the inspection is flow assurance, that there's a flow assurance concern and we're trying to understand that better, then we will also provide the integrity at each of those locations, right? The only difference is there's a little bit of the scope of work setup, so to speak, or job planning setup that is typically a little bit different from an integrity program to a flow assurance program. Flow assurance is typically not worried about, every foot or every 2 foot. We're looking at bigger jumps and trying to build a picture, versus integrity is typically going into defined locations and getting a sample size or a set distance of scan or representative of the pipe itself. So a little bit, we'll jump into our over-inspection or over-strake inspection. This is kind of unique application for Tracerco because of the way that we do our CT scan. Anything that basically fits inside of our CT tool, we can inspect, right? So that's a huge advantage on a large scope project, which is typically what we will do, where we will do multiple lines or multiple risers, jumpers, so to speak. They all have different coatings on them. Some are pipe in pipe, some are strake covered. And operators don't want to have to remove the strakes and try to put them back on, or just remove them and leave those spots bare. So unique application over strakes. This is a case study where we actually did a gas export riser integrity inspection for life extension. We do quite a bit of life extension work. This was here in the Gulf of America. We were initially scoped of work to do 5 different locations, and we were going to inspect 1 meter of inspection at each location. And we were going to do that by using our fast and full scan methodology, right? Where we get 9 fast, or this particular project was 9 fast scans for each full scan. And we did find significant wall loss in one section of the riser. We'll show you that. What do I mean by 9 fast and 1 full? So, sorry, hitting the wrong button there. So in the background, the math that our guys are seeing in the ROV shack, they build what they call the sinogram, right? And I'm not sure if it's showing up as great on this computer as it does in the real world, right? But basically, this is an inspection of a single location over time. So this isn't distance, this is time. And as we scan, or as the tool spins around the pipe, the more revolutions we get, the more data we get, so the more clear the picture, so to speak. Now we have the ability, so to give you an example, we'll just take a run-of-the-mill pipe size, an average, 8-inch diameter, 10-inch diameter, 3/4-inch wall pipe, it's probably going to take somewhere in the neighborhood of 5 to 6 minutes to get a high resolution scan. Now, we have to have a high resolution scan to actually pull physical measurements from of the pipe wall. However, with a single lap, we can identify whether there's any change to the norm, right? So if we've scanned and we verify we're in good pipe, there's no defects, then we take a step, scan, take a step, scans, take a step, scan, and repeat that process for 9 times. If we don't see any change in signature, then we know that there's been no defects identified. So we can speed up that inspection location by doing that sampling, and then periodically every, let's say 9, 15, some clients do every 15, where we take a full measurement, and then we can tell whether there's any gradient or general slow wall loss across that, right? All in the effort to speed up the actual inspection, because time is money offshore, right? So what this does is any defects in the pipe show up as these, what we call swirls. And even in here, you can see very small ones that are in there. So that is after one loop. This is after 20 or a full tomographic scan, where we can actually pull measurements, and we can see those defects pretty clearly, right? So that's very clear how we will typically set up an inspection project. Give you some examples. Here's actual real world, the tool being delivered to a pipeline with Strakes on it. Now, I won't tell you that we can do every straight line out there. Couple of things that we have to, so we kind of have to take each project on its own face value, right? So we need to understand, what is the total OD, and that includes fin height, right? Because we have to be able to fit into our frame that we can scan. And then the other thing is our length of travel, because we're traveling straight, basically, our length of travel is going to be defined by the space or the helical rotation of the fins itself. Doesn't mean we can't get a larger inspection. It just means that we can't walk the tool by ourselves. We can only walk a certain distance until we come up against the fin, to where the ROV has to rotate us around the pipe, and then we can walk again. Now, we can keep track of that, but it's just, I don't want to misrepresent and say, okay, once we're on it, like we would a standard pipe, that we can just scan on our own without any ROV intervention at that point. Couple of closer up images of the pipe actually while it's clamped around the tool. So we have actually clamped, and we are scanning on this. And this is what I mean about that helical rotation of the fins, right? So our clamp mechanism are feet that come in, soft feet that come in and centralize us on that pipeline, right? So as we walk down the tool, those feet open, move, and clamp. We can only, but that's going to walk in a straight line. So as we walk, we're going to run in and hit that fin, so to speak. And hopefully y'all can see my cursor there. At that point, we would walk up to the final point, and then the ROV, we would declamp, and the ROV would rotate us around to that next fin, and then we would walk that distance again. So whatever the client wants as far as a sample setup. And then here gives you some actual results of what we found, right? So if we look at this was a gas line. This was near touchdown point. We can see there's a heavy layer of concentrate. So we got gas inside the pipe. Here's the pipe wall itself. We've got a condensate layer sitting inside, and then we can clearly see in here that we're getting some wall thinning compared to this side here. We, of course, can measure this on the CT image itself. I've just got this on here because it looks good on a presentation. But we can clearly see the degradation of the wall, as well as, of course, we can put this, and we will put it in the report in a wall plot if you're used to using or seeing ILI data similar to that. We will take all the measurements that we have and, of course, wall plot that so that you can get a wall plot here. But these are great resources to take to senior management and actually give them a visual and show them, here's exactly what my pipe wall looks like. So real quick, I'll jump on here to a little bit more about the fast scanning, right? So we can see now this is just a different orientation, but again, we are looking at, in this image, we are looking at a single location on the pipe over time. This is time, or if you can imagine, this is 360 degrees, right? We base that over time. We know how fast the revolutions are going to take. And as we scan, this is two different sinograms on this particular CT image. This happens to be a heavy wall pipe, single wall, but heavy wall pipe. And you can see that there's no defects, there's no swirls, there's no lines. We just get a little bit grainier image, and then that image sharpens up in the sinogram, and then the data from this sinogram produces the CT image, right? And then where we have defects in the line, or where we start to see wall loss, we can see those jump in swirls. So if I bounce back and forth between those two images, you can clearly see those defects start to pop up on the image itself. So it's a very quick and it's very easily identified by our offshore personnel. Now, one thing I'll clarify before we move on. When I talk about we do a full scan and then 9 fast scans or 15 fast scans, however we want to set up that particular project. If at any point we're in those fast scans and we see a defect, we will automatically at that particular location go into a full image, because we need to measure at that point. We need to come to you and say, hey, here's what it looks like. Here's what the defect looks like. We can clearly identify with the operator if is this a manufacturing defect and we're not worried about it, please move on, or is this something of concern? Let's get high resolution images until we step out of that defect, and then start the fast scan process again until we find or until we run into another defect. So don't think that we're going to miss it and just arbitrarily scan on, or say, hey, there's a defect here, but it wasn't in a full scan and we couldn't get the proper data. The other important feature is that because we get this real-time data, before we come to shore, we know we've got the data. We know all the data is good. The other thing is if we're in a spot inspection location and you're actually in an area of wall thinning or in an area of a defect, what we don't want to do is come off the pipe, come home, and everybody go, oh my God, I wish we would have got more information here because we were still in a defect. We see that, we measure that, we understand that offshore, and we've done this multiple times where now all of a sudden we've increased that inspection location. The client says, no, we need right here, right now, while the vessel's in the field. Let's get more area of representation in this particular location. All right. And I'll answer any questions on this at the end. Now we'll jump into flow assurance. So for wax detection, Discovery has been used for flow assurance 14 years now. It's a phenomenal tool. It typically marries with our Explorer technology that can quickly go find anomalies, and then Discovery can come in and actually tell the operator what the material is, what the structure of the material looks like, how bad it is, and how long it is, right? All those are phenomenal pieces of information that go into a proper remediation. I mean, based on our research, we've probably got 70 to 80% of remediations fail on first attempt. And that's either because the problem was much more significant than originally understood. The problem was something other than, which is a high probability, than what was anticipated. And then finally, it's going in blind, thinking, okay, well, maybe we're not making any progress, and in fact you are. So we can actually monitor that progress before people just, they feel like they're spending money out there and not gaining anything. We can actually tell whether you're making progress, and that should be able to give you a relatively close idea of when we think, or when you think we're going to break through, or we're going to start to see some natural gains on the remediation process. Right. So the first case study, and I guess, the reason why we're talking about wax here is because wax is probably one of the most difficult things to identify, right? And that's typically because the density differential is very close to your oil, right? So the tighter the densities, the harder it is to see and understand and verify what is wax and what is oil. Asphaltenes, pretty easy peasy. Hydrates, scales, sand, those are big density differentials, easy to see and kind of stick out like a sore thumb. Wax, on the other hand, depending on the wax, some are pretty significant density difference to their oil. Some are very, very tight, and that gets difficult to determine. So here's a case study where or two case studies. One of them is one application, and another is a different application where we've been able to go in and develop tools within our software to help us pick out that wax, right? And I'll show you those. The first case study was a full field inspection of a gas system, flow lines, jumpers, gathering lines. Initial scope of work was integrity, right? So we were brought out to take a look at the integrity of this system. After our initial data started coming in, we started seeing wax. We started seeing a buildup, and we verified through density that it was wax. It was clearly wax. And at that point, our scope of work increased because now not only was the focus integrity, but the focus was wax deposits, lengths, amounts, because now they went into a dual scope of work where not only were we getting the integrity data, but they must have the flow assurance data because they were getting ready for remediation. Excuse me, whether that be chemicals, whether that be mechanical, whatever they decide to do, that's not our realm of expertise. Our realm of expertise is understanding what is the material within the flow line, and how bad it is, right? Where is it located? So that the flow assurance engineers, the people with the real knowledge and the understanding, and the vessel companies, the people that go out and attack these problems, have the data they need to attack it the right way, right? This particular system we'll show you here. Let me go in. We call it our differential analysis tool. And what this allows us to do, if you can imagine stripping away layers of an onion, right? So we get a clean pipe reference. And at that point, we can then subtract the pipe in the software. And what that allows us to do is it eliminates what's called our inherent wall bleed. So when we look at flow assurance, because the density of the steel is so high, and anything that we're going to see internal to the pipeline is so low in comparison to that high, there's a light layer around the internal of the pipe that will have what's called wall bleed, right? Where it's making that super high dense to low dense transition. And what I mean by that is 1/8 to 1/4 of an inch right next to the wall gets a little fuzzy for us, right? What is material? Or it's masked by that density bleed in. And sometimes they want to know what that is. So we are able now to go in with what's called the differentiator or differential analysis tool, where we can go in and strip that pipe away, and we can plug in, hey, computer, show us everything that you see that is in that wax density range. And what I want to show you by comparison, now these are heavier layers of wax, so we wouldn't necessarily need it on these particular images, but I wanted to utilize these to show you the difference. Here's the actual CT image as is, right? So we've clearly can see this wax buildup in the lower section of this pipe. And then this is with the differentiator tool, right? So what this shows you is even though this shows a very small layer, that layer is actually bigger than what it looks like right here, because now we've stripped away the pipe, and that is just the wax that is sitting around the pipe. Again, down here, similar situation, but yet this red location over here is the reverse. So we've stripped out anything, and you can see the wax. Where this becomes valuable is in this fourth image. Here's another one where it's actually worse than what it appears, and that is, again, because of that wall bleed section down there. But here's where the interesting comes up, where it gets very, very tight. And say, hey, do we have wax or do we not have wax into this system? Are we producing wax? Here, we can go in where it's a very fine layer of wax around the bottom, where it doesn't necessarily stick out to us. It doesn't show up as well in the CT because it's right on that wall. But with that differentiator tool or the analysis tool, we can drop out that pipe wall and just pull the densities into that wax. And we can clearly see right in here, that wax section and this light layer around the bottom. So it allows to say kind of, hey, here's where we're starting to drop out, or we're ending to drop out on wax. Again, good pieces of information. Or if that's all we're seeing in the line, and we were in an integrity project, it lets you know, hey, look, you probably need to add some chemical. You need to do something, a quick little treatment in here to make sure that this wax layer that's in this pipe is eliminated now and not pulled forward or get into a situation where it becomes a lot more critical, right? Something like this also, if you're trying to do a pigging campaign, you're probably going to be able to do a pretty aggressive pigging campaign with a wax layer like that. However, if we get into wax like this, you're going to have a hard time pushing that much volume through that line. So those, again, go into critical decisions, so that the operator's not flying blind. Third and final case study we'll look at. This was actually a flow assurance project. This was a client that was experiencing quite high DP and reduced throughput in an oil line. They brought us out at this point to try to verify exact material that was causing the restriction, the severity, the location from the platform, yada, 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 as they were obviously gearing up for a remediation campaign, needed to understand whether they were going to be able to do a chemical campaign. If it was mechanical, where was it? Can we reach it? How are we going to get to it? Those different questions that run through the flow assurance people's mind when they gear up for one of these projects. Excuse me. We use what we call a contour tool, right? So again, we're getting down to trying to split hairs here about what's wax, what's oil, and so forth. And we developed a contour tool that can go in and build a contour around certain densities that we may not be able to pick out just blatantly with the naked eye. In this particular situation, it was a significant problem. Significant wax built up, and it was located from the touchdown point out about 8,500 feet. It was quite a significant problem, obviously, that had been built up over a long period of time. Now, what they ended up doing with this, I'm not sure. I do know that they're looking at bringing us out again this year. So they have done some remediation to it, and I think they're going to want to have us come out and see, A, what the progress is, and B, or if they're clear. A couple of examples here to show you what that looks like, right? What does that contour tool look like? And it's very hard to see. I'm sorry, on my computer here. This is a 100% fully open bore, right? So flow assurance, we've got the oil in here. With our technology, any location or pixel basically inside of this image, we can go in and measure the actual density of the material that's in the pipe. So we can measure the material on the outside. Obviously we can measure the wall of the line itself, and anywhere in here we can go in and measure density. If we get right on this wall bleed section and we can't see something, we can use that differentiation analysis tool that we talked about before, where we can go clear that up. And now we have what we call our contour tool. Well, if you look at this image over here, we can look at the different densities, but you can see where this is picked up, this contour of lower dense material, which is the open bore of the oil and all of the wax that is built up around it. And then we can kind of measure that, what's my bore percentage? Here we have a 31% open bore channel. If I jump forward, we've got a little bit more open bore channel here, but you can see that contour that's coming around and this material involved. And then probably the worst situation here where we're super restricted down to 21% bore channel open. Again, it highlights where the technology has come in two different applications or two different niches that we can use to our technology, kind of bolt-on software analysis stuff that enhances the value of that technology. And everything that you've seen today is all real world. These are all actual projects, images that were produced in the field on projects that we have done. So I'll kind of wrap it up here, give you some quick oversight of the technology. Again, fully non-intrusive inspection technology. And we say non-intrusive, we mean that. Hopefully there's no need to remove Strakes. There's definitely no need to remove any coating, concrete coating. I don't care. It doesn't matter. Pipe and pipe, very difficult to inspect. It has zero effect on our ability to inspect the pipe or multiple pipes within that and provide the flow assurance data all in the same time. So there's very little preparation to the pipe. Marine growth doesn't affect me in the least. I do have to have access, so there is some preparation, especially if you're on the sea floor, that we will need 360 access to. We get real-time inspection data, right? That's faster analyzing the information, more informed decision making, and there's almost zero chance of us having to come back to the beach and everybody then determining, well, I wish we would have got more data. We have that ability to make those critical decisions offshore, and a single tool that's able to do the full spectrum of the inspection. So any pipe that's on the scope of work, any size, any materials, we can handle it all with that single inspection tool. Again, bringing real value to you. It, again, combines the integrity and flow assurance in a single scan. Again, there's no difference. So there's no added time. There's no change in the way that we acquire the data. Once we acquire the data, we get the data. That's the flow assurance and the integrity data. It's all in the same data. It's just a matter of how we report it and look at it, right? So there's no value whatsoever in us not providing that information. So we will always provide the flow assurance as well as the integrity data, no matter what the primary scope of work is for that project. And high scanning speed enables greater coverage per location. Again, we talked about that fast scan technology and how we utilize that, which has massively increased how much area we can cover and still get all the pertinent information that you need for your system. Oh, okay. So a lot of information I went over there. So hopefully you saw value in that. Hopefully you've at least got an understanding of the technology, how we're actively utilizing that offshore for our customers, and maybe that sparked some questions for you. So I'm happy to open the door and see what we had.
Thank you, Jim. Excellent work. Some really good case studies in there and lovely imagery too. We are going to move to take some questions now. If you haven't asked your question already, now is the time to do it. I can see we've got some good ones though, so we'll go straight in. The first question is from Tiago, who asks, how long does a full scan typically take?
So typical radiation principles, right? So always remember time, distance, and shielding, right? So the more shielding or the more material we're scanning through, the longer amount of time we need. So as I mentioned, I think I did a little bit earlier, a typical high resolution image scan is going to take somewhere in the neighborhood of 5 to 7 minutes. Now, if we get into 20-inch carrier pipe, we may have to stretch that out to 12, 15 minutes to get the high resolution. But the bulk of the stuff that we do fall in that 5 to 7 minute range for the high resolution scan.
Okay. I hope that answers your question, Tiago. A couple of questions here that are related. So Ashish is asking, can the tool scan through all types of coatings and insulation? And then the second part is, what are the minimum and maximum pipeline diameter and wall thickness that the tool can inspect?
So perfect. Great question. So no, coatings don't affect us, right? Other than it adds a little bit of shielding and it could take a little time. Say, for instance, if it's concrete, right? Concrete's more dense. Typical wet insulation, there's no difference between the water and the insulation or enough to make any difference on how long we scan. So no, coatings don't affect us other than, there could be some situations we haven't run into it. There could be some situations where you've got some damaged coating or some disbonding that won't allow the tool to kind of soft clamp to, but that would be the only thing I could think of from a coating standpoint, right? The tool that we have is perfectly set up so we can inspect anything from 6 to 26.5-inch total OD. That's kind of what'll fit within our clamping mechanism. We have done smaller and we can do smaller, but it takes a special clamp application, basically an extra piece of insulation to grow the size of the OD to 6 inches so our feet physically will clamp onto it, right? But 6 to 26.5-inch OD. And then steel, again, it's going to depend on whether it's concrete or whatnot. But we're talking a couple inches of steel. So probably 1.75 to 2 inch would be about our max.
Okay, we've got lots of questions coming in, so we'll go straight to the next. How does the tool differentiate between wax, scale, sand, asphaltene, and other deposits? Also, can this provide a volumetric percentage or mass estimate of wax in a pipeline?
Okay, so yes and no, right? So it differentiates by density, right? We are 100% density. We're measuring the density of the material that we're seeing inside the pipeline at any spot, right? So whether it's oil, water, sand, wax, they all have a different density. And we actually go in and measure the density. So we're basing that measurement off of density. We know asphaltene is going to be somewhere in the 1.2 grams per cc density range, right? So if we see a lot of material that's in that density range, we know it's an asphaltene. Okay. I'm sorry, I lost the other portion. Was the second half of that?
Yeah, the second half was, can this provide a volumetric percentage or mass estimate of the wax in the pipeline?
Yeah, I would say yes, but I'm not sure I could do that, right? So we can give you a like we talked about, a percent bore opening in a location, and then we're doing multiple of these locations. So you would have to assume, let's say that we did a scan and we've got a 30% bore opening in this location. We went down another 50 foot and we scanned, and we've got a 25% bore location opening. Somebody would have to run the calculations and assume that was pretty evenly distributed through there, and then you could do that, right? Because I agree with you, that's important, because especially if you're going to pull this material onto a vessel or something, you kind of got to have an idea of how much storage or how much material you're going to have to pull out of this system. But I can't go in and rubber stamp that between point A and point B, you're guaranteed to have this nice linear change from 30% bore to 25% bore. But again, you should have a whole lot more information than you would if you didn't have that.
Great, thank you. The next comes from Mohammed, who asks, when is this inspection type mandatory? I think that's what you're asking, Mohammed. When is this inspection type mandatory?
So, I can speak for where we are here in the Gulf. There's a couple of scenarios, right? Now, when we say this inspection type, I'm saying inspections in particular, right? There's no government rules, or there's nothing that says you have to use our technology on a pipeline, right? But inspection of pipelines are going to be regulated by either DOT, if they're a transmission line, Department of Transportation here, and they will have intervals of inspections that require that line to be inspected every so often. And that could change depending on the results of the inspection. And then typically offshore or further upstream is going to be BSEE, and it's going to be for life extension. That's your primary driver. Unless, again, you've done some inspection and you found some issue, then the government may come in and go, okay, well, we want you to monitor this pipeline now, and we want it every 5 years or 3 years. And that'll be dependent upon the severity of the defect that was found, if that helps. But primarily, it's going to be DOT driven, or it's going to be life extension driven.
Brilliant. Pedro is asking, for integrity inspection, what is the typical inspection rate in terms of pipeline length covered per hour or per day?
So pipeline cover per hour. So to give you an idea, we'd have to run the math, but we can do typically a full meter of inspection in a couple of hours, right? And then the frequency of those inspections, or the locations, what we call location, that really needs to be defined by the operator. We will be happy to go in and say, hey, look, here's where other operators are inspecting. Here, we've got a pretty good idea of what BSEE's going to want to see as far as their locations. Always going to be a touchdown, upstream, downstream, touchdown, the likes. But it will definitely depend. The total length or time per location we need to understand from the operator, how much inspection do you want? Do you want a foot? Do you want 5 meters? What is that? What's that number for y'all? And then, are we using the full and the fast screening, and at what interval? So are you using 9, 15, 20? What are we going to do? We will set that up per project.
Great. Brilliant. The next is from Alan, who asks, can you scan riser bends, tube turns?
At touchdown point, I'm assuming that's what he's asking. Yes.
Mm-hmm. Yes, that's a nice quick one.
Yeah. No, we do that frequently.
Great. Tiago, is this tool able to identify wax hidden leakage?
Wax hidden leakage. So I'm assuming you're talking about a hole in the pipe that's plugged by wax?
Potentially. This one you might get back to.
Yeah, we're going to see if it's that defect in the pipe. We're going to see the defect in the pipe, whether the wax is there or not.
Great. Okay. Vose Babu is asking, is this technology applicable for onshore crude oil pipelines?
No, we get that asked all the time. No, we're primarily subsea with this. We have been asked to bring it topside. We haven't really delved a whole lot into that business case. But the systems that we have now are 100% designed for subsea.
Great. A Mr. Hamish here asking, what is the advantage of Tracerco regarding intelligent pigging? Presumably, what is your...
Yeah, great question, right? So, there's pros and cons to both, right? So I'm not going to come in here, I've got a reputation in the industry for years of trying to be an honest guy and with my client. There are pros and cons, and there are applications for both, right? Intelligent pigging is phenomenal technology. There's some great companies out there that do that, and it gives you 100% inspection of the pipeline, right? The downside is the risk of the pig itself, right? You have to stop production. So however long, and especially if you've got some buildup in a pipe and you're having to go through a long progressive pigging campaign just to get the pipe, the internals, into enough shape for the ILI to run and get accurate data, it's substantial when you're talking about weeks before they can run an ILI. And we do a lot of pig tracking, so we know how these projects work, right? We've been on ILI runs that have taken not the actual run itself, but the prep leading up to the run, 2.5, 3 weeks, right? All while you're not producing. So, it doesn't take a rocket science real quick to figure out, how big that number is going to get in loss of production. But you get 100% of that inspection, right? So you can walk away. Whereas we are going in externally. I wish somebody would do 100% of a flow line. I could probably retire tomorrow, but that hadn't happened yet. We're going into discrete locations, right? So our clients are going in either we're following up an ILI run because an ILI run has been done and they've identified these key locations or these defects. And then we go back and we monitor those without having to stop production. Or if they are strictly either unpiggable pipelines, or we have operators out there that just won't do an internal inspection, they'll do 100% external. They feel comfortable enough based on their corrosion modeling in association with their flow assurance modeling and looking at, okay, if we are going to have any issues, those issues are primarily going to start here, here, and here, and then they will send us to those locations.
Great. Somebody here missed a bit. Don't worry, Rajesh. We will be sending the full presentation within a couple of days. But the question is, for waxy pipelines, is this intended as a targeted, non-intrusive inspection where the location of wax buildup is already known?
Yes and no, right? So we will always end up trying to go to locations and verifying that there's no wax buildup, right? Even if we've been sent to an area. Let's say you've done some sort of pre-work and got what you think is an idea. We think we got wax from this location to this location. We're always going to go, it would only be prudent to go past that location and verify nothing's there as well as prior before. Or we've done some explore work, which is our kind of our other technologies that we didn't discuss today, where we can go out and build a profile, density profile of that pipeline fairly quickly, and then follow up with anomalies with discovery, where I can't go in and say what it is. I can just say, hey, something's not right here. And that gives us a location to go in with discovery, right? But other than that, your flow assurance people and engineers are going to have a relatively decent idea of where they think the wax is going to start and build up. And that at least gives us a go-to point, a start point.
The follow-up question to that is, can this technology be applied to multi-layer flexible risers with significant wax deposition?
Absolutely. Well, flexibles don't bother us at all from a flow assurance. Let me try that again. From a flow assurance standpoint, flexibles are no problem whatsoever.
Great. Very reassuring. Our next question says, can the discovery tool be used as a primary integrity assessment method, or is it best suited as a supplementary tool to validate other inspection results? Great question.
Only use discovery forever. That's it. No. I wish that was the case. That's very client driven, right? I can just kind of tell you the breadth of what we have and what we see and what we do. We have operators that use both. There are obviously unpiggable, or what they call difficult to pig pipelines, where it's just not feasible or it's too risky for them to use ILI. We have operators that use both technologies. Again, like I talked about, where they will run an ILI tool, they will get the bulk of the data, and then we will periodically go back and measure the growth of those anomalies that they have identified. And then, like I said, we've got some clients that, they just use ILI data because we pig track for them. We know that they don't use anything else. And then we've got a couple of clients, especially here in the Gulf, that won't pig. They just use 100% external inspection.
Great.
That's very, very, very. That's very much up to the client palette and their risk profile and integrity program.
We had another question here which kind of relates to that. So when comparing it to UT ILI, how does the accuracy of this tool stand up?
Very, very good. I've got different presentations where we've qualified almost near UT. We won't claim that. We'll claim we're more on the lines of MFL, right? As far as our capabilities. But yeah, no, we've done concrete coated lines where we've gone in and almost nailed exactly what UT said. UT is a good technology.
Mm-hmm. A question here about what are the deployment requirements for the tool?
So work class ROV and a active heave compensated crane. So we have, our tool comes in its own subsea carry basket. We will go overboard by the crane. They will drop us to the seafloor. And at that point, the ROV will come get us out of our basket. They'll do a wet mate stab into a flot on the front porch of the ROV and then deliver us to the pipeline. And we are working, I guess I'll tease this a little bit. We are working on our next generation that will be ROV deployable, much smaller, much faster, much shinier, neater.
Okay.
I'll just leave it at that. I don't want to talk too much about it, but it'll be groundbreaking if we can get it there, right?
Got it.
It's not there yet. Currently it is overboard in our basket, active heave compensated in a work class ROV.
Great. Question here saying, do the external thermal installation coatings on jumpers cause you attenuation problems?
No, none at all.
Easy answer. Brilliant.
Easy peasy work. We do a lot of jumper inspection.
Okay, time for just a couple more, I think. So the question here is, what type of integrity problems are best suited to this type of technology? So where does this work best?
Yeah, so as far as integrity problems, anything general wall loss, erosion, corrosion, pitting, flow assurance, obviously, those are the realms of defects and problems that we're going out to. And as far as pipeline, like we talked about, anything, except for flexibles from a integrity standpoint. we can see all the layers. I can see carcass damage. I can see all these different aspects in a flexible, but I can't see the details in between the armor and wires, so to speak. So from our standpoint, from an integrity standpoint, we try not to mess with flexibles. We're being pushed that way quite a bit, but we don't want to go out there and try to claim we can do something that can't be done. From a flow assurance standpoint, flexibles don't matter, right? I mean, it's irrelevant to me of what the external coating, pipe configuration, so forth, for me to actually go in and see the flow assurance issue internal to the production stream.
Lovely. A question here. It says, how does this technology change things like the way I do my inspection planning?
So, if you're going to do, if you're used to doing ILI, it's just going to take a little bit more work up front to try to determine where those inspection locations need to be, right? Other than that, I don't see where it changes. There's not a whole lot of difference in what we're doing versus them when it comes down to the nitty gritty of data acquisition. We're all trying to get data. That's it, right? So it doesn't matter, so to speak. It doesn't matter what the shiny tool that we're using or we're putting on there. It's the data, right? That's what matters.
Yeah, I'm glad you mentioned data, because our last question is this: how does this technology improve the quality of the data that I get compared with what I'm used to?
Well, again, it depends on what you're used to, right? There's quite a few technologies out there, but I guess what I can say on that, the quality of our data is very, very good. And again, the value add of what we produce is we can produce our CT images that gives you an actual visual of what the pipe looks like, what the material in the pipe looks like. B, we can put it in a wall plot like you're used to seeing if you're used to UT and other technologies. It's very similar there. But we can go through any coating and we can do any pipe. So if you've got some heavy wet insulated pipe, some single wall, FEE coated pipe, some pipe and pipe, different pipes, different sizes, it's irrelevant to me. As long as it'll fit in my tool, I can inspect it and get the data for you, right? So it's a single tool mobilization. And then I will always bring you back to the value add of having that flow assurance information. I can't tell you how many pipes we've inspected that have had, a layer of scale buildup or asphaltene or something that they weren't anticipating. And that's an early detection. That's an easy fix. And you never have to worry about that becoming a loss of production issue, right? Most of the time these things are easily dealt with online chemical injections that can remediate online or very quickly before it becomes a major issue. It's a huge value add to the technology.
Great. I think we will wrap it up there. Thank you so much, Jim, for your time and your expertise. Really enjoyed having you today.
No, thank you, Elizabeth. As always, we really appreciate it, but more importantly, to everybody who's out there on the line, listen, we totally understand how time is valuable. So we can't thank you enough for spending this 45 minutes to an hour to come in to listen to a couple of our case studies, and hopefully you see value in it.
And we did get some particularly good questions today. So thank you so much for the attendees. If we didn't get to your question, it will be passed to the team at Tracerco and they will then feed back to you directly. Equally, if they've got something more that they want to elaborate on, they will write back to you directly. Do look out for the full recording of the session, which will be delivered to your inbox within the next couple of days. And finally, if you'd like to read a regular copy of Well Pipelines, you can click on the button that is appearing on your screen now and register for free. So thank you so much, Jim, and thanks everyone, and goodbye.
Thank you all. Have a great